Welcome to Dr. Anima Upadhyay's Chemistry in Technology lecture series. If you have not subscribed my channel, please subscribe it. Also, like and share my videos among your friends and in the student communities. Today's video is about removal of electrons from an atom or ionization. So, I have already described the structure of atom in my previous video in the same series, where I have described that an atom is electrically neutral because it is made up of a nucleus containing protons and neutrons, and the number of protons in the nucleus is exactly the same as the number of electrons which revolve around the nucleus. Electrons are negatively charged, protons are positively charged, and neutrons does not carry any charge. They are neutral. It is the number of protons which is also called the atomic number. Electrons keep on revolving around the nucleus because of the electromagnetic force of attraction between the two oppositely charged particles. These particles are called subatomic particles. Among these particles, it is the electrons which is the fundamental particle. What are fundamental particles? The particles which cannot be broken or which cannot be splitted into small units. Protons and neutrons are not fundamental particles. It is only the electrons which are called the fundamental particles because we cannot tear them apart. Now, how to remove the electrons? We already know that electrons are kept in the orbits and they keep revolving down the nucleus because of the electromagnetic attractive force between the protons and the electrons. So, if we want to remove an electron from a neutral atom, we need energy higher than this force of attraction. And this can be achieved from electromagnetic radiations such as X-rays, gamma rays, which have very high frequency and low wavelength. So if we expose these atoms to such electromagnetic radiations or heating the substance to a very high temperature or exposing it to some catalyst, we can achieve the removal of electron from the atom. And this energy, which is capable of removing an electron from a neutral atom, is called ionization energy. Because with the removal of an electron, the atom is no longer neutral. It now attains positive charge because it has lost one negative charge, resulting into a positive ion called cation. So now the atom is ionized and the energy which is capable of removing the electron is the ionization energy. For the removal of second electron from the atom, now it is not neutral but from a cation, is more difficult than removal of first electron from a neutral atom. So with every successive removal of an electron from a cation, the ionization energy required keeps on increasing. The reason behind it is that the force of attraction in a cation increases with the increase in the positive charge or with the removal of electron. So first ionization energy is less than second ionization energy, which is even less than third ionization energy. So if we see first, second and third ionization energy is highest compared to second, which is higher than the first. What are core electrons? The electrons which are close to the nucleus. That is, the electrons which are in the shells that are close to the nucleus. These electrons are called core electrons. And the electrons which are farthest from the nucleus are called valence electrons. To remove the core electrons and to remove the valence electrons, which will require more ionization energy. It is for the removal of core electrons, the ionization energy required is more than the valence electron. Because it is a simple concept. The thing which is close to the nucleus is more strongly attracted towards the positive charge compared to the electrons which are farthest from the nucleus. There will be some shielding effect also. And the electron-electron repulsion also will be there. So, they will be loosely bonded compared to the core electrons. And therefore, the ionization energy required to remove the valence electron will be less compared to the removal of electrons from the core electrons. Now, ionization energy is represented as IE, both capital letters, I and E. And the energy is denoted as kilojoules per mole, which is a unit of energy, same as calories. The ionization energy, it increases when we move from left to right in a period. But it decreases when we move from top to bottom in a group. We all know that the elements are arranged in a periodic table in 7 periods and 18 groups. There are around 118 elements. So, the columns which are vertical like this, they are called groups. And the rows which are horizontal, they are called periods. So, this is group and this is a period. When we move from top to bottom in a group, the ionization energy decreases, although there is an increase in the atomic number. The number of protons is increasing. But with the increase in the atomic number, the next electron which is added goes to the next shell. It does not occupy the same shell, which results into the increase in the radius of the atom. And this is the reason the electron moves farther from the nucleus. And I have already told you that as you move away from the nucleus, the ionization energy required will be less. This is the reason when we go from top to bottom in a group, the ionization energy decreases. But when we go from left to right in a period, the ionization energy increases. Although the atomic number is increasing, but the radius of the atom is not increasing, because the next electron which is adding to the atom, goes into the same shell, and this results into a shrinking of the radius because the positive charge in the nucleus exerts more attraction to the electrons occupying the same shell. So the radius is not increasing. Instead of increasing, it is slightly shrinking. Therefore, the ionization energy increases when we go across the period from left to right. I will stop here. Learn the concept and try to understand and imbibe it. Watch the video 2, 3, 4 times. We'll talk more about the ionization energy in my coming videos. Till then, take care of yourself.